Good afternoon. Our today's topic of discussion is maxima and minima with problems. For maxima and minima, we should know what is increasing function and what is decreasing function. Increasing function, a function f x is said to be increasing function, said to be an increasing function if as x increases f x also increases. For example, if we take f x is equal to x square, if we put x is equal to 1, f x is 1. If x is 2, f x is 4. X is 3, f x is 9. As x is increasing, f x is also increasing. Therefore, dy by dx is positive for increasing function. Dy by dx is positive for increasing function. Now, decreasing function, a function f x is said to be decreasing function if as x increases f x decreases. As x increases, f x decreases and vice versa. For example, if we take f x is equal to 1 by x, as x is 1, f x is 1, x is 2, f x is 1 by 2, x is 3, f x is 1 by 3, x is increasing and f x is decreasing. Dy by dx is negative, for decreasing function. Maxima and minima. Now, we will discuss about maxima and minima. Let us consider the function y is equal to f x. Then draw the graph of function y is equal to f x. This is point A and this is point B. At the point A, x is equal to A and at the x is equal to B. Let the graph of f x be as shown in the figure. We see that the curve turns at the points A and B. These points are called turning points. We see that at the point A, tangent is parallel to at the point A, and at the point B, tangent is parallel to x axis. Tangent is is parallel to x axis. Therefore, slope of tangent at these points is 0, because tangent is parallel, therefore slope of tangent is 0. Therefore, dy by dx is 0 at these points, We see that at the point A, function stops decreasing, and begin to increase. Therefore, value of the function f a is minimum at the point A, and x is equal to A is a point of minima. Similarly, at the point B, function stops increasing, and begin to decrease. Therefore, value of the function f b at B is minimum, and x is equal to B is the point of minima. These maximum and minimum values, together are called extreme values. Now, we will discuss about working rule to find maxima and minima. Working rule to find maxima and minima. Step 1, let the given function is y is equal to f x. Step 2, find dy by dx and put it equal to 0. Now, solve the equation obtained in step 1, obtained in step 2 to find the values of x, Let it be x is equal to a, b, c. Now, test these values. For maxima and minima. For testing these values there are two methods. First method, find d2y by dx square. Put x is equal to a. If d2y by dx square at x is equal to a is positive, then x is equal to a is a point of minima. X is equal to a is a point of minima, and f a is minimum value. F a is minimum value. If d2 by dx square at x is equal to a is negative, then x is equal to a is a point of maxima, and f a is minimum, f a is maximum value. Now, इसलिए second method second, if dy by dx is positive if x is less than a slightly, and dy by dx is less than 0 if x is greater than a slightly, then dy by dx changes sign from positive to negative. Therefore, this is a point of maxima. If dy by dx is negative if x is less than a slightly, and dy by dx is greater than 0 if x is greater than a slightly, then dy by dx changes sign from negative to positive. Therefore, this is a point of minima. If dy by dx does not change sign if x is less than a or x is greater than a slightly, then there is neither maxima nor minima. It is a point of inflection. Similarly, in first method, if d2 by dx square is not positive, not negative, it is 0, then it is a point of inflection. First method d2 by dx square 0 हो जाए, then it is a point of inflection. If dy by dx does not change sign, then it is a point of inflection. We can show this by a table. X f dash x less than a slightly, greater than a slightly, f dash x is positive greater than was say negative, then there is a point of maxima. F dash x is negative for less than a slightly and positive for greater than a slightly, then there is a point of minima. If f dash x is positive for less than a slightly and for greater than a also positive, then it is neither a point of maxima, neither a point of maxima nor minima. Similarly, if f dash x is less than 0 for x less than a slightly and less than 0 for x greater than a slightly, then it is neither a point of maxima nor minima. Now, we will solve some problems about maxima and minima. Our question is, find the maximum and minimum values of the function f x is equal to x cube minus 6x square plus 9x minus 8. We will solve this question. As we have learnt, in first step we put the given function is equal to y. We put y is equal to x cube minus 6x square plus 9x minus 8. Now, find dy by dx. Differentiating with respect to x, we get 3x square minus 12x plus 9. Now, equate it equal to 0, put dy by dx is equal to 0. Therefore, 3x square minus 12x plus 9 is 0. Taking 3 common, x square minus 4x plus 3 is 0. Now, factorizing this, x minus 1, x minus 3 is 0. Therefore, x is equal to 1 and 3. Now, we will test these values for maxima and minima. Now, we will test these values for maxima and minima. For this, find d2 by dx square. Our dy by dx is 3x square minus 12x plus 9. Now, d2 by dx square, again differentiating, it is 6x square minus 6x minus 12. Now, put x is equal to 1. At x is equal to 1, d2 by y dx square is 6 into 1 minus 12 minus 6, which is negative. At x is 1, this is minus 6, which is negative. Therefore, x is equal to 1 is a point of maxima, and f1 is maximum value, or fx is x cube minus 6x square plus 9x minus 8. Therefore, f1 is 1 minus 6 into 1 plus 9 minus 8. This is 1 minus 6 plus 9 minus 8 minus 14 plus 10, this is minus 4. Therefore, minus 4 is maximum value. Minus 4 is maximum value. Now we will test x is equal to 3. Our d2 by dx square is 6x minus 12 at x is equal to 3. This is 6 into 3 minus 12, 18 minus 12 is equal to 6, which is positive. Therefore, x is equal to 3 is a point of x is equal to 3 is a point of minima, and f3 is minimum value. f3 is equal to 3 cube minus 6 into 3 square plus 9 into 3 minus 8. 27 minus 54 plus 27 minus 8. This is minus 8. Therefore, minus 8 is minimum value. Now, we will discuss another question. Our next question is, find the maximum and minimum values of the function minus x plus 2 sin x when x lies between 0 and 2 pi. We will solve this question. First of all, put it equal to y is equal to minus x plus 2 sin x. Then find dy by dx. This is differentiating with respect to x. Derivative of x is 1 and derivative of sin x is cos x, minus 1 plus 2 cos x. Now, put it equal to 0, then minus 1 plus 2 cos x is 0. Therefore, 2 cos x is 1. This implies cos x is equal to 1 by 2. When cos x is 1 by 2 at cos 60, and in fourth quadrant this is cos 360 minus 60 means cos 300. Therefore, our x is 60 degree and 300, or we can write pi by 3 and 5 pi by 3. In radians we can write pi by 3 and 5 pi by 3. Now, we will test these values for maxima and minima. For this, we will find d2 by dx square. dy by dx is minus 1 plus 2 cos x, derivative of minus 1 is 0 and derivative of cos x is minus 2 sin x. Now, put x is equal to 60 degree. This is equal to minus 2 sin 60 डिग्री माइनस 2 साइन 60 डिग्री की वैल्यू होंगी है √3/2 कैंसिल हो गया दिस इज माइनस √3 विच इज़ नेगेटिव therefore x is equal to 60 degree or pi/3 is a point of maxima because double derivative is negative therefore this is a point of maxima and f of pi/3 is maximum value. Fx is minus x plus 2 sin x therefore f of pi/3 is minus pi/3 plus 2 sin pi/3 minus pi/3 plus 2 sin pi/3 की वैल्यू है √3/2 this is our maximum value. Now check x is equal to 300 or 5 pi/3 d2 by dx square is minus 2 sin x as dy by dx is minus 1 plus 2 cos x derivative of 1 is 0 and derivative of cos x is minus sin x therefore d2y by dx square is minus 2 sin x at x is equal to 300 this becomes minus 2 sin 300 minus 2 sin 300 now we can write 360 minus 60 which is equal to minus 2 sin 360 minus 60 is minus sin 60 minus plus 2 sin 60 the value of sin 60 is √3/2 this becomes √3 which is positive therefore x is equal to 300 is a point of minima. X is equal to 300 is a point of minima and f of 300 or f of 5 pi/3 we can write 300 as 5 pi/3 also is minimum value. Fx is minus x plus 2 sin x therefore f of 300 degree is equal to minus 300 degree plus 2 sin 300 degree minus 300 degree plus 2 sin we can write 300 as 360 minus 60 which is equal to minus 300 degree plus 2 minus sin 60 degree equal to minus 300 degree minus 2 sin 60 the value है √3/2 this is our minimum value. This is our minimum value. Now we will discuss another example for maxima and minima and also for point of inflection. We will discuss a question of point of inflection. Determine the position of the point of inflection. Determine the position of point of inflection of the curve given by given by the equation y is equal to x minus 2 square into x minus 7. We will solve this question. Y is x minus 2 square into x minus 7. Find dy by dx. Differentiating with respect to x,